know the methods, and also know the and, and also know the content very well in physics as well as
Okay,
in ethics.
that's fine. Yes, Matthias.
Okay, my expectation is by the end of this course, I should be well equipped with the kind of teaching strategies to use uh, for the different topics, and also be well equipped with the content knowledge of the physics curriculum, like the physics itself, so that I become a better teacher and make my students like the physics as a subject.
That's fine. Yes, Gideon. Hello.
Okay, sir. Mine is I'm hoping to be able to blend the um. Hello, sir.
Yes, you are online. You are on. We can hear you loud
Hello,
and
hello,
clear.
sir.
Yes, we can hear you, Gideon. Proceed.
Hello.
Hello, we can hear you.
Okay, so I
Proceed.
said okay. I'm hoping to I'm hoping to be able to blend the teaching strategies with the content in physics, so that in the near future, if I'm given the mantle to teach the physics, I won't shiver, but I'll be able to deliver and give out my best.
Okay, that's good. Evans.
Okay, sir. I also
Yes.
hope to understand the what the content is, what is content, pedagogy, and then also their relationship, so that when I'm in class, I should be able to combine them effectively to delivering my lesson content. Thank you.
All right. So each and every one of us here has an expectation, and you realize that their expectations vary. So, but then there is a kind of relationship that exists among your expectations, that you become not just content specialists, but individuals who can blend the content with the pedagogy to enhance learners' understanding of the concept of physics. So let's look at the general knowledge base. To become a very good or effective teacher is not just a one-day show. It is not just a single event whereby you will say that, oh, based on the training or the workshop I went for today, I have become a better teacher. You society. And the process through which teachers, we master both content, society, teachers should be able to master not just the content, but also the various pedagogical strategies or the instruction where we have learners who are auditory learners, where we have learners who are visual learners, where we have learners who are kinesthetic learners. All these learners are in your classroom, and you should be able to employ pedagogies that will cater for all these learners or the learners that you have in your classroom. Now, knowledge bases of teacher education previously have focused on content knowledge of the teacher. So previously, we believe that, or researchers or people do believe that, to be a better teacher, you should be a content specialist. So once you are grounded in the content of physics, then it means that you can be a very good teacher. But more recently, the focus has shifted, where this time it is not just about mastering the content, but then there should also be a focus on your pedagogy. So people believe that once you have enough pedagogy, even with little content, you should be able to teach. And so research on pedagogy has focused on the application of general pedagogical practices. So in the classroom, we now begin to look at the various pedagogical approaches, collaboration, illustrations, demonstration, peer tutoring, we begin to look at all these pedagogical practices with the sole aim of enhancing learners' understanding of the concepts, and specifically in the area of physics. Now, several researchers have therefore rekindled the discussion about the importance of teachers' content knowledge. So you realize that there is that debate where one believes that to be a better teacher or an effective teacher is the one who is a content specialist. Then the other group is of the view that an effective teacher is the one who is pedagogically inclined. Now, let me find out from you, from your point of view, who do you think? Yes, hello.
Please, I just had a notification that our own is face to face.
Hello.
Hello, sir.
Yes.
I just get the notice that our own is face to face.
You just had a notification that
our own is face to face.
Your own is face to face.
Yes, please.
Please kindly check from the timetable. Check from your timetable. All courses are online except for the following study centers who will blend face to face with online. So do well to confirm whether you are having it face to face or online, because Mofratro Study Center, you have to blend face to face with online. And I don't think this is the first time we are having the online session.
Okay. But yes, but
come again.
Our coordinator just called me that our own is face to face. I'm a little bit confused about it.
All right. But still, we have some who have to have it online. All right, so let's proceed. When we finish, I'll find out from Code UCC whether this course is for online for all centers, or there are some centers that are supposed to take it face to face. So those who are supposed to go for face to face, you can go for it for now. And those who are supposed to have it online, you also join.
Okay.
I believe we are good to go. Can we proceed? All right. So I asked the question that what are your views? Who do you think an ideal teacher should be? Should an ideal teacher be a content specialist only, or a pedagogically inclined person? Or what do you think? Yes, Matthias. Yes, Matthias, proceed. Your hand is up.
Okay, for me, I think that for you to be a very good physics teacher, you should be pedagogically inclined and also be inclined in terms of the content as well. You should possess both of them. So that is my view. It helps to make your teaching not being static. You become dynamic, and then you'll be able to express yourself the more in teaching. I mean, use different strategies to teach. Thank you. Hello.
Hello.
Yes, sir. I don't know whether you heard me.
Unfortunately, I heard you, just that I was rather muted. So I was talking, I just realized I have muted myself. So I heard you, Matthias. Okay. All right, so let's take the views of Gideon. Yeah, hello, Gideon. Hello.
All right, so as a physics teacher, I think you should be able to. Yes, sir. I think you should be able to blend the two. You should have the pedagogy and also the content as well.
Okay. Yes, Evans.
Yeah, I said you should have the.
Okay, so I believe that as a qualified and then an experienced teacher, you should know what to teach and then also how to teach it. Because knowing what to teach and not having the knowledge of how to teach it will be a limitation. So in order to become very effective in class, you have to blend the two, have the knowledge in the pedagogy and then also the knowledge in the content, so that you can basically know how to deliver the lesson content to your student, and then also to apply different pedagogical method, as there may be some form of differentiation in learning, because all learners are not the same. So if you have the content knowledge only, it means that you'll be stuck. How do you employ strategies that will help you to meet the needs of the other students who are not
Okay.
at the same level as others? So I believe that blending the two is okay. Thank you.
Thank you very much. In fact, thank you to you all for the wonderful submissions that you have all made. So, as a teacher, you need a blend of the two. You should be able to blend your content and your pedagogy to bring about effective teaching and learning. Now, let's look at the types of knowledge that a teacher will be required. Remember, we go to the classroom not with our own kind of information to go and deliver, but anything that we go to the classroom to teach are based on the national goals and standards. So we have the national curriculum, from which we have the various subject syllabus or syllabi. So everything we go to the classroom to teach are being taken from these documents. So what prospective teachers we need to know and we should be able to do should be grounded in what our future learners need. So what is the role of physics teaching? And when you take the physics syllabus or the science curriculum, it is stated there that individuals who go through physics instruction should be able to become critical thinkers. They should be able to be individuals who are problem solvers. And so as a teacher, these are the things that we need to know. Once we know these things, our teaching or the methodologies that we apply will be those that will help our learners to become the critical thinkers that we want our learners to be. So we need this kind of knowledge. We should have this kind of knowledge. We should know the kind of learners that the kind of learning that will ensure that our learners become the kind of learners that we want them to be. So national goals and standards will reflect these needs and have strongly converged in recent years on what it is that future teachers of science we must know and we should be able to do. So presently you realize that we are in an era where technology, in fact, cuts across every sector. Education, we have technology there, and now technology is even changing the ways through which we deliver our lessons. And so presently you realize that I think just not long ago, teachers, I mean the in-service teachers, even had a course, was it on cyber security training or something of that nature, as a form of their professional development. All these are geared towards helping the teachers to be abreast with current happenings so that when they get to the classroom, they can also deliver well. So it is sometimes noted that in order to teach well, teachers, we must possess a certain identifiable knowledge base. And the knowledge base of the teacher consists of wisdom and prudence. So when we talk about wisdom here, we are talking about your ability to think well about the nature of the world, your ability to make good use of the knowledge that you have as a teacher. Then we use this wisdom to discover prudence. And when we talk about prudence, we are talking about your ability to think about how and why we should act in order to accomplish a particular end. So why should my learners behave this way? Why should I employ this pedagogy? Why should I use these teaching learning materials? So everything that you do in a classroom, you're able to tell us the why and the how of doing that particular activity. Please, can we proceed? If you have a question, you can ask. If we have to proceed, you kindly let me know. All right. So the knowledge base of the physics teacher consists of three elements. So you should have the content knowledge, you should have the pedagogical knowledge, and then a blend of the content and pedagogy, what we call the PCK, which is your pedagogical content knowledge. Now, when we say content knowledge, what comes to mind? Yes, what is content knowledge? Yes, Evans.
Yes, sir. Please. It talks about the subject matter. The
Okay.
subject matter. Yes, the subject matter. Yeah.
Okay. Yes, any other view? Yeah, Matthias.
Okay. Yeah, as Ivan said, it's about the subject matter and then the let's say what the syllabus. The pedagogical knowledge talks about the procedures that you use to teach.
So with content knowledge, as said by Evans, it is the knowledge of the discipline itself, and it's sometimes your dispositions. Now, CK or content knowledge consists of knowledge of physics concepts and the methods of acquiring this kind of knowledge. So various documents describe the content students must learn, and teacher preparation documents describe the or give of topics that the teacher must teach the learners. And teacher preparation documents also ensures that our teachers who will be going to the field to teach these concepts are well versed in these content areas. And so teachers must know what they are expected to teach their learners. And that is your content knowledge. Now, this content knowledge is knowledge about the subject matter to be learned or taught. And as a teacher, you should have broad and current understanding of the major content areas of physics. So you realize that even the program that you are going through, sometimes you are taking certain content courses and you do ask yourself, am I going to teach these things also at the senior high school where my services will be needed? Because you look at the content of Newtonian mechanics, you look at the content of atomic physics, and you compare with the senior high school level and you realize it is far above that. But what you are supposed to know is that as a teacher, you should have a broad and current understanding. So even though you may not need some of these content at the basic, the senior high school level, you need to have a broad knowledge base of the subject so that whenever you are teaching, you realize you are very competent in the subject that you are handling. So the knowledge in these areas include mechanics, electricity and magnetism, heat, and the unifying principles of light or waves, and modern physics. So all these are content areas in physics that you as a prospective teacher, you should be well versed or have a broader knowledge in them to be able to deliver them effectively. Now, this knowledge is includes knowledge of concepts, knowledge of theories, ideas. So when we take certain laws in physics, you should be able to have some kind of knowledge concerning those laws. When we take some theories in physics, you should be able to have some ideas or some knowledge on some of these theories. So in the case of physics, content knowledge of the physics discipline itself includes the following. So knowledge of facts, knowledge of concepts, and knowledge of procedures. So what we call the factual knowledge, what we call the conceptual knowledge, as well as procedural knowledge. In all these knowledge bases, the physics teacher should show enough understanding of these areas to be able to deliver their lessons effectively. Please, any question before we proceed, if you have a question? Hello?
Hi, sir. I think we can proceed.
Benjamin. Hello, Benjamin. Hello. All right, let's proceed. So let's look at factual knowledge. Now, when we say factual knowledge, what comes to mind? Yes, what is factual knowledge? Yes, any volunteer? Okay, yes, Matthias.
Okay, I think uh, it's the knowledge that is based on facts, like
Okay,
facts that are gathered, like proven facts. So these
okay,
are the knowledge that's not just about what you think, but what is the fact, is the factual knowledge.
okay. So can we mention some of these facts that as a physics teacher, you should know? Yes, what are some of these facts that you must know as a physics teacher? Evans, your microphone is on. Hello, Evans.
Yes.
Okay, yes, what are some of these facts? Hello? Please, can you hear me? Please, can you hear me? Gideon,
Yes, sir. We can hear you.
please, can you hear me?
Yes, please.
Okay. All right, so let's proceed. So with the factual knowledge, as Matthias mentioned rightly, facts and ideas of physics. So the basic elements the physics teacher must know to be acquainted with the physics discipline or solve problems. So for example, it is a fact that electrons are negatively charged particles. It is a fact that like charges will repel and unlike charges will attract. It is a fact that heat will flow from a warmer region to a colder region. Basic definitions, basic understanding or knowledge of units of quantities. All these are facts that you and I, as physics or prospective physics teachers, we should know. Now with conceptual knowledge from the word, so from conceptual knowledge, we have concepts. And this describes the interrelationships that exist among basic elements within a larger structure that enable them to function together. So it consists of the teacher's ability to explain physical phenomena and also understand qualitatively without the use of formula or equations. Your knowledge of classifications and categories, knowledge of principles, knowledge of generalizations, knowledge of theories. All these are knowledge, conceptual knowledge that the teacher you must have. So an example is the physics teacher being able to understand and explain the knowledge that density is mass per unit volume and the implications that this understanding has for physics teaching and learning. So we know that the idea of density being equal to mass over volume can help us to identify whether objects will float or sink in liquids. The idea that heat flows from a warmer region to a cooler region gives a better idea or understanding that when the such flow will only happen when there is a change in temperature. It means that without an absence of temperature change or temperature difference, we are not going to experience that understanding that temperature or heat moves from a warmer region to a cooler or a colder region. Now, procedural knowledge, that is procedure. And so here, if a teacher wants to conduct an experiment, you must know the step-by-step strategies that you have to follow to perform that particular experiment. So procedures are like recipes in that they give the concrete steps that have to be executed in order to reach a goal. And so you realize that anytime you want to conduct physics experiments, we do provide these steps. So, for example, we want to find the relationship between voltage and current, the effect of resistance in a circuit. To conduct such an experiment, we provide some step-by-step strategies that you are to follow. So we will say that connect your circuit, add this quantity, vary this quantity, make your observations, record those observations, and you're able to tell us everything that happens within the circuit. So good procedures can, for example, enable students efficiently solve, let's say, a quadratic equation, or based on the idea that density is mass per unit volume, and that if an object is heavier than a liquid, the object will sink. If an object is less dense than a liquid, the object will float. Based on these ideas, our learners can even construct a toy ship, and this ship may float or it will sink based on the density of the ship compared to the liquid or compared to water. And another example can be how to apply Ohm's law to calculate electrical resistance. Please, any question on these knowledge basis of the teacher? Hello?
Hi.
Yes, if you have a question, you can ask. All right,
No
so I think Gideon says we can proceed. Now let's look at pedagogical knowledge. So as we mentioned earlier, your knowledge of the various teaching strategies. And this talks about the generic why and how. So you realize that when we talk about pedagogical knowledge, it is more general. And that is what we mean by generic why. So general, we look at why am I going to use this particular method? And when we get to the PCK, now becomes the specific, because now you have to bring into it your content. So pedagogical knowledge consists of knowledge of brain development. So you have an understanding of the various developmental stages of the learner. And this helps you to develop your lesson in that line. Cognitive science, collaborative learning, classroom discourse, classroom management. All these are knowledge that the teacher you need. So you get to the classroom, you should be able to manage the classroom effectively. When your learners are talking or when they are misbehaving in the course of the lesson, how do you deal with such situations? How do you pair your learners to ensure maximum teaching and learning in the classroom, collaboration? All these are knowledge that the teacher you need to be effective in the classroom. So pedagogical knowledge of the teacher is a teacher with such a knowledge understand how students construct knowledge. The teacher understands how learners acquire knowledge. The teacher understands how they develop habits of mind and positive dispositions towards learning. So if you have a strong pedagogical knowledge, you are able to both intrinsically and extrinsically motivate your learners to learn. You're able to arouse the interest of your learners in the subject that you teach. So pedagogical knowledge requires understanding of cognitive, social, and development of theories of learning. So when you have an understanding when it comes to the cognitive developmental theories such as those and as a physics teacher, you must understand what constitutes effective teaching. And you brainwashing. So more often, we may go to the classroom and you realize that our learners will be finding it very difficult to understand the concept that we are teaching. Sometimes it could be that you started from what they do simpler issues may prevent your learners not to get a better understanding of whatever concept that you want to teach. So it also represents a situation. Sorry. So let's now look at PCK. PCK. So with PCK, here we now have that content-specific overlap. So you are going to blend content and pedagogy, and it deals with the specific why and how to of teaching a given discipline. So if we take physics, if I take the concept of forces, then the question I will ask myself, how will I teach forces for my learners to understand? If I take the concept of heat, how do I elicit learners' prior knowledge on heat so that they will understand the concept that I'm going to teach? And that is your PCK. So this is a type of knowledge that is unique to teachers. And it is based on the manner in which teachers relate their content to their subject matter. And the integration of the synthesis of this knowledge and the subject knowledge comprises pedagogical knowledge. So when you look at this diagram, and I think we have all seen this diagram before. What name is given to this diagram? Hello?
Yes, sir.
Yes, what name is given to this diagram that we are seeing?
Is it as in said, intersection?
Come again.
I'm saying that it's like in mathematics, like intersection, like in a Venn diagram, we have an
Good.
intersection.
So this is a Venn diagram. And
Yeah.
let us explain the various components of this Venn diagram. So we have the content knowledge. So basically, we have heard, there are times we do hear people say, this is a professional teacher and this is a non-professional teacher. So if one or an individual is a professional teacher, then what it means is that the teacher is in the region where we have the letters written in color red. It means you lie in the middle here, PCK. So there are teachers, the non-professional ones, they are the content specialists. So probably the person did BSc physics with no education component. And so the person have a very good content knowledge. And what differentiates you from that teacher is that you have pedagogy in addition to the content. And so you are able to present the content very well to the learners. Unlike those who are the content specialists. Now, PCK is complex, and it is always the result of many years of classroom experience. What this means is that if you finish your program of studies and you are being posted to St. Augustine's College, Wesley Girls Senior High School, Mancransu Senior High School to go and teach physics, you realize that the physics teacher you went to meet over there who has taught the subject for 5 years, 10 years, will be well established or well grounded in teaching the physics concept, because PCK is developed as a result of the many years of his or her experience of teaching the subject. And like the saying goes, that experience is the best teacher. When you are in the field for a very long time, your continuous years of teaching the subject, you're able to develop that experience in teaching. And we can describe this knowledge as knowledge in context. And so for Shulman, he is of the view that PCK embodies the aspect of content most useful to its teachability. What it means is that every content and the methodology that fits that particular content. And so a strategy you will use in teaching kinetic energy or kinetic theory of matter may differ from the strategy you will use when you are teaching heat. And so every strategy that you use in the classroom is not going to be the same. The various pedagogies, they are going to change based on the concept or the content that you want to teach. So based on what you are going to teach today, you may select demonstration. But tomorrow, based on what you'll be teaching, you may select collaboration. Probably putting your learners together to share ideas among themselves, come out with their understanding and share with the whole class. Then the teacher, you just guide them. You become a guide to the learners. Now let's look at the composition or categories of PCK. So one knowledge or one composition or category of PCK is knowledge of representation of subject matter. You should also have an understanding of student conceptions and preconceptions. And when we say student conceptions, we are talking about what your learners know about what you are coming to teach. They are preconceptions. And so learners already have an understanding of the concept that you are coming to teach. And so it is always important that as a teacher, you elicit these preconceptions, what they already know. Sometimes you find out that what they already know may be correct or incorrect. And it will surprise you that this is what they have been, these false ideas or knowledge is what they have been holding for years. And as a teacher, as you elicit these ideas, you're able to get a better understanding of what my learners already know about the topic, what they don't know, what they know right about it, and what they know, but it is not the right knowledge that they have. This helps you as a teacher to plan your lessons, sometimes to deal with some of these misconceptions. You should also have a general pedagogical knowledge. You should have curriculum knowledge, knowledge of educational context, as well as the knowledge of the purposes of education. Now, in addition to all this knowledge, PCK, your content knowledge, and your pedagogical knowledge, there are some general knowledge that you need to have. And so let's mention them. What are some of these general knowledge and skills that you need to be an effective teacher? What skills do you need to be an effective teacher? What are some of the general knowledges that you need to be an effective teacher? Yes. Hello. Hello. Please, can you hear me?
Yes, please, we can hear you.
Yeah, so my question is, what are some of these general knowledge, the general skills that you need to bring about effective teaching and learning, or to make you a better teacher? Yes, Gideon.
Okay, say as a physics teacher, you must be very good in mathematics.
Okay. So does it mean all those who are doing physics are also doing mathematics? And are we saying that if your mathematics background is low, you can't teach physics?
I'm not saying that, but you see, it entails a lot when it comes to mathematics.
Okay.
So if your background in math is no good, at times you're going to suffer. That's when it comes to calculation.
All right. Yes, Benjamin.
So, communication skills.
Okay. Why do you think communication skills are important?
As a teacher, you need to have a good communication skills for your lessons to be interesting, for your people to have more interest in your lesson. And once again, there will be no burden in the class.
Okay. Yes, Evans.
Yes, sir. Please, assessment. Yes,
Okay.
yes, as a prospective physics teacher, you need to have the knowledge of how to assess your students. The procedures to use,
Okay.
because it is this that is going to get you information about the students, the curriculum that you are teaching, so that you can also make effective decisions that will help your students. Yes, thank you.
Okay. Gideon, your hand is still up. Yes, Matthias.
Okay, so I think one thing that as a physics teacher you should also know is one the age or the level of your students, and also their relevant previous knowledge that they have about what you are going to teach.
Okay. And why do you think it's necessary? You have an idea of the relevant previous knowledge of your learners.
Okay, I think it's necessary because maybe what they already have, the content, the knowledge they are having might be contradictory to the facts. As we stated earlier, for a teacher, you must have the factual knowledge. So since you are going with the factual knowledge, you should be able to know what they have, so that you what they already have in mind as being their own facts, so that you based on that and then teach them what the actual fact is.
Okay. Yes, Evans, your hand is up again.
Yes, about the content, the entry behavior.
Okay.
Yes, yeah, it's important. So it's very important because it helps you as a teacher to plan and then organize your instructional materials. Because when you go to class and you pose a question, maybe, and need to make a diagnostic assessment to see the level of their understanding of what you're about to teach. At times, you go to class and then you realize that about um, 3/4 of the class do not have an idea of what you are going to teach, and then also the knowledge you have to build on they do not have. So you have to stop that lesson and then go back, make sure you teach the knowledge they require before they can start that lesson. Before you do that, so entry behavior is very, very important, because it will help you to basically know what to do. Perhaps you have to stop the topic you're about to teach something else before you come back to that topic, so that effective teaching can take place. Thank you.
Just said it means as teachers we should know that there are times you may get to the classroom and you realize that what you want to teach, if you are to go straight to it, your learners will not understand. And go and teach vectors. But you realize that your learners do not even understand the concepts of Pythagoras theorem that well. And you need this when you are teaching vectors. And so you have to pause and introduce them to it. Then from there you can proceed. Now, in addition to all that you have said, you should also have planning and preparation skills. So you should be able to plan lessons, write very good lesson plans, lesson types. You should be able to create unit plans. So you know that for currently we are dealing with semesters at the senior high school. And so once you know that these are the topics I'm to treat for year one, you should be able to plan them so that you follow them accordingly. So as a prospective teacher, you should also demonstrate a thorough planning, demonstrate through planning how you integrate the various pedagogies that we have mentioned. You realize that when you plan your lesson, you are able to think in the course of your planning, you think ahead of the class. Which strategies will work? If it will work, how should I go about it? How do I motivate my learners? How do I capture the interest of my learners? You're able to do all these things when you plan your lesson. So because you have planned, you get to the classroom and you're able to know all the strategies that you are going to use. But if you don't plan, you get to the classroom and you realize that when your learners say they don't understand, then what you'll be doing is that you keep on repeating the same strategy you have been using over and over and over again. The same strategy they have been complaining that they don't understand, it will still be the same strategy you will continue repeating. Sometimes it is due to the fact that you didn't plan before going to the class. So you need to have that planning and preparation skills. In addition to planning and preparation skills, you should also have quality teaching skills. And here what we mean is that you must understand the difference between teaching by telling and teaching by helping students construct their own knowledge on the basis of experience. It is not all the time you get to the classroom that your learners will ask you a question that you have to just give them the answer straight away. I think we look at this, is it in methods or so, where there are times the word and power of constructivist forms of learning. And we all know that
Hello, sir.
when we talk about constructive,
Hello, sir. Hello, please, can anyone hear me?
Yeah. We can hear you.
Yeah, sir, please, can you hear us? It's like your voice fades out and then comes back again.
Yeah.
I was thinking it's my end.
No.
It's not-
hello, hello,
Hello,
hello,
sir. Yeah, we
Yes, sir,
can
we
hear
can
hello.
you
hear
can
now.
you.
hear you.
I lost my network.
Okay.
All right, so I was talking about teachers using constructivism or constructivist ideas in their classroom. So you realize that for the constructivists, they are of the view that learners should be able to make meaning from what is being taught. So you get to the class, most of the activities you do are activities that are supposed to help the learners come out with their own understanding of the concepts that you are going to teach. And so here, quality teaching, we know, can help learners become quality students. When students are able to come out with their own understanding, when they're able to generate meaning from the things that you teach them, it sticks more than when you just tell them answers. So if, let's say, there is a problem, you have after teaching a certain concept and there are some problems to be solved, instead of solving all the problems with them, maybe after solving the first or the second, the third one, you can now put your learners into groups, then they solve it themselves. In the process of solving, they are going to share ideas among themselves. They're able to explain their reasoning behind the things that they do right. And if they're able to get it correct, you realize that these things do stick more than when you, the teacher, you keep giving answers to every question they ask. Now, another knowledge or skill you need to have is inquiry practices. So as prospective teachers, we should be able to use these practices to help our students come out with their own understanding. We should be able to use this knowledge to help them to be familiar with concept change and its relationship to constructivism. And they should be able to assist students in the procedures whereby knowledge of nature and technology are constructed. So inquiry-based activities, these are activities where you only provide guidance to the learners as they come out with their own understanding. So you should have this knowledge as well. The knowledge when it comes to cooperative or collaborative learning. Now, research has shown that peer tutoring is one of the most effective teaching strategies when the learners, they teach themselves. And you bear witness with me that there are some concepts that after lectures, you get a better understanding of it when your friend or your colleague explains them again to you. Is that the case? Or this is just a guess? Hello?
Yeah, it is.
Good. So you realize that when your friends explain those concepts again to you, you get a very good understanding. So peer tutoring or collaborative learning is one of the most effective strategies that we can use as physics teachers. Whilst helping the learners to understand the concept being taught, it also develops the learners' interpersonal skills. So when they are in groups and they learn,
Hello, sir.
yes.
Please, I have a question.
Okay.
You made mention that we have to teach from known to unknowns, and you cited an example like when you are going to teach vectors and you come to realize that your people don't know Pythagoras theorem and the rest. And I want to ask, very soon we will start our off campus, and
Okay.
I've prepared to teach, let's say, vectors for I'm
You
using 45 minutes.
okay.
Let's say I'm using 45 minutes to teach vectors. And
Okay.
during the lesson, I came to realize that the people don't understand vectors. They don't understand Pythagoras theorem and the rest. You have to cancel what I've prepared and teach the Pythagoras. What I've already presented to my external vigilator that this is what I'm going to teach.
Okay. Yes, what do we think? Yes, Evans. Okay, yes, let's hear from Matthias. Each and every one of you will share his view on this. Yes, Matthias.
Okay, so for me, I think that you just you use a little time to uh, teach them the basics. You will not use the whole time. So you use the when you teach them the basics like the Pythagoras theorem that you are talking about, I think just give them a brief idea of how it is. and they are able to understand that part, then you continue by introducing your topic. If it is better that you introduce what you have prepared and you're unable to finish, rather than to go and teach something that you didn't prepare on. That's my suggestion.
Good. That's a very good submission. Yes, Evans. Hello.
Yes, sir, please.
Okay.
I think I do agree with Matthias, because
Okay.
you have an objective to meet. So when you go, I think that's why we have studied pedagogical knowledge. You need to know series of steps or procedures that you can employ to quickly go through Pythagoras theorem for them to understand, so that you can go ahead with what you are prepared for.
Okay. That's good. Yeah, yeah. Hello. Gideon.
Hello, sir.
Unfortunately,
I
we
think
can't hear from you.
for me, I think in the right way. Hello, sir. How you can hear me?
Yes, we can hear you now.
Hello, sir.
We can hear you.
Hello?
Continue.
Hello, sir. Hello.
Gideon, you are on. Continue. Proceed.
Hello. I was saying
Hello.
that for me, I think as a teacher, as my brothers just said, you have an objective. I'm talking, sir. Yeah, you have an objective to meet, but if you think that what you are teaching the kids, they are not getting it, I think you can communicate.
Unfortunately, it seems you have lost Gideon. But in addition to, yes, Matthias, you want to say something again?
Yeah, I just wanted to add something. I think as we were saying, planning is very, very important. And if we are always planning, we must always factor all these things into it. Since we are going to have our off campus somewhere, and then maybe the students they are not the ones that will be teaching always. We must always have it at the back of our mind that something like this could happen, and then have a plan B. If we make it that if our plan B became plan A for work, that means that we are going to have a little problem there. So we always have plan B in such a way that we can quickly go back uh, and then let them understand our concept before we move on.
Okay. Yes, Evans, your hand is up again.
Yes, sir. So I wanted to add to what Matthias was saying, that for the lesson planning, so because of these inconsistencies or unforeseen circumstances, you need to make time, or you create time for that, because it's a possibility that when I go to teach, this is my plan, but then I know the entry knowledge, I know the knowledge that they have to acquire to be able to understand this topic. Therefore, if I go to the class and then they don't have that knowledge, what will I do? Then you just figure that, or you just factor that into the time frame. So in case you go and it happens, you have already compensated for that. Then you can teach, make it very briefly and continue. Yes.
All right. Thank you all for the wonderful submissions you have made. So you realize even in your lesson planning, there is a column or a section you call remarks, or it is no longer in the lesson plan again.
It is.
What's the purpose of the remarks? What's the purpose of the remarks column?
I think it's there so that if you are unable to accomplish your lesson, you state it, or if there is anything that prohibited you from maybe finishing, you state it, and then if you are to reschedule your time to that one, you state it then.
Okay, that's good. So, Benjamin, take note. You see, if you go to the classroom, in addition to what your friends have said, and you realize the concept you are trying to introduce, your learners are not getting it, and that is why you find their prior knowledge before you even start the concept. So the fact that you have prepared on vectors and your supervisor knows that it is vectors you are going to teach, I think it was also written as part of your relevant previous knowledge that learners have an idea on the Pythagoras theorem, and in the course of the lesson, you revise that ideas. And that is where you get to know that, in fact, what I even presume that they know, they do not know. And briefly, like Matthias said, you in the course of your planning, if you plan, you're able to make room for such things. Now, if at the end of the lesson, you're unable to finish all your objectives because you have to cater for this unforeseen circumstance, that is where the remarks column also comes in. So you stayed there. Probably the lesson was not fully taught and it has to be continued maybe in the next another day. Normally, what we do is that lesson was successfully taught. Lesson has been successfully taught. What it means is that you're able to achieve all your objectives. But if you couldn't finish, you also state in your remarks column that you couldn't finish and it has to continue another day. When the supervisor is there and the supervisor realizes that what you are teaching, your learners are not getting the concepts, and so you want to help the learners get the basic things before you move on to what you want to teach. We all understand all these issues. We all know that these are some of the unforeseen circumstances you are likely to encounter in the course of your teaching. And so we are not rigid when we come. That because you have stated that you are teaching vectors, whether you like it or not, by hook or crook, I must see you teaching vectors, even when your learners are not getting it. So there is that flexibility too. Okay, Benjamin.
Okay, sir. Thank you.
All right. So we said that with collaborative learning, it does not only bring about an understanding of the concept you are teaching only, it also helps your learners to develop interpersonal skills. Your learners learn to be tolerant. Sometimes in the groupings, you know, if you are in a single-sex school, then you may, if you know or you have a good idea of your learners, you can have mixed ability groups. If you're in a mixed school, you can have mixed gender. So when you are in a mixed school and you do not have enough idea about your learners, you can just put them in this mixed gender group. So if 4 in a group, probably based on the number of boys and girls, you put them in those kind of groups. Sometimes you realize that even in the process of putting your learners in the group, there are some learners who may want to be in a particular group. So you get to know that, no, this guy, sometimes you get to even know that there is some kind of friction among your learners. Some do not want to develop their interpersonal skills. And all these learning strategies helps them to build those skills. Then also problem and project-based learning. Problem as well as project-based. So there are times you have to use projects. There are times problem-based learning where we connect the things we teach to their real-life problem-solving ability. So as we do this, we enhance their critical thinking skills. And this is a way we can integrate diverse elements of science, or in our case, physics, into technological as well as societal problems. So when you are teaching the concept, we try to link them. When you are teaching density and you are teaching it raw for, mass per unit volume, they solve problems, and you're unable to link it to its real life applications. You see, the learners do not appreciate what you are teaching. But when you're able to link them to the real life applications, they're able to appreciate the concepts that you are teaching. So as a teacher, helping your learners learn and apply what they know to real life situations makes their learning more meaningful. And so we should try that. There are multiple representations. And you can do multiple representation of your instructions when you have planned your lesson. So multiple representation is whereby this time you think of using audio, you may think of using visual aids, audio, visual, sometimes you make use of video simulations and what have you, all in an attempt to help your learners understand the concepts that you are going to teach. Now, our learners possess such knowledge When they have such knowledge, they become more professionals in their thinking than novice problem solvers. So they see the problem from different angles. So as you are teaching the concept, they see videos, or they saw a video demonstrating what you want to teach. They have seen diagrams. So all these give them different angles to think whenever you give them a problem to solve. Then you should also have an idea or knowledge about their preconceptions as well as concept change. So remember that your learners have a certain prior knowledge, as I said earlier. This prior knowledge may be right or wrong, and it is going to be the responsibility of you, the teacher, to change the wrong ideas that they have about the concept that you are going to teach. So let me find out from my prospective teacher. Whenever we are in the home or in our houses, and the brightness of the light begins to go deep, what do we normally say? Is it, how do we call that? Hello, how do we term that?
We usually say low current.
Low current. So let me find out, is that the right term to use? Is that the right term? Yes, no. Hello?
Yeah. No, sir.
What? So if no, then what is the right term?
For the low current.
Mm-hmm. You said the right term is not low current. So what is the right term?
Perhaps low voltage. Yes, voltage. I think low voltage. Current.
Okay, so Ivan says he thinks it is a low voltage and not a low current. I saw Benjamin squeezing the face. Benjamin, what's the problem?
I'm still thinking about what to say.
You are still thinking about it, whether it is going to be low current or low voltage.
Yes.
Yes, Matthias, what should it be? Is it a low current or a low voltage?
I think it's a voltage.
It's a voltage. So how do we help our learners to overcome this misconception? So the right term is low voltage, and there is nothing like low current. So how do we help our learners to overcome such a misconception? Yes. Yes, Matthias.
Okay, I think when we make them know what the difference is, when we teach them what a current is and then what voltage is, they will be able to identify the differences and then get to know that what we are receiving is the voltage.
In a practical scenario in the classroom, you can just make a simple series circuit. And I believe you all know what a series circuit is.
Okay.
So when what is the series? When they are in series, what does it mean?
Yes, so we say a circuit is in series when the flow of current is in one direction, only one direction. Thank you.
Evans, we can't hear you.
Yes, please, I said we say a circuit is in series connection when the flow of current direction, single direction. A direction is one. Yes.
Okay. So a unidirectional mode of current flow.
Yes.
Okay, good. So another simple way of saying it is that when you break one part of the circuit, you realize that all the components are in a straight line. Are we okay with that? All right. So you have a series circuit, and you can have about 2 or 3 bulbs in that circuit. what you observe is that when you check the current through the circuit, the current is going to be the same throughout the circuit. But when you measure the voltage across each bulb, you realize the voltages are not the same. But what will be observed is that the higher the voltage, the higher the brightness. So the bulbs that show a higher brightness, you realize that their voltages are also high. And those with lower or dim or lower brightness, they are going to get the lower voltages. And you'll be able to let the learners get to know that no. So it was not the current that was low. It was the voltage which was rather low. So I think this was a misconception that we have as prospective teachers. Benjamin is one of them. Benjamin, is that true? Benjamin.
Yes, please.
So that was a misconception. So it is low voltage, and you should be able to use a practical activity to demonstrate that to your learners. And when you're able to clear such a misconception, they now get a better understanding. They should be able to think scientifically. All right. Then again, knowledge of learning cycles. Knowledge of learning cycles. So some of these learning cycles, an example is what we call the 5E. The letter E, the letter E, 5E learning cycle. We have the 4E, the 7E. They are all learning cycles that shows or helps a teacher how to go about instruction. So if you want to use, let's say, the 5E, the teacher begins by, we have the first stage being the elaboration stage. Is it the elaboration? Let me be sure of this. We have explain, we have evaluate, we have elaboration. What again? I have forgotten these things. But the 5E is a learning cycle that we can use. I've forgotten the meaning of all the E's, but we can find them. So these are learning cycles that prospective teachers we can make use of. Now, prospective teachers, we must demonstrate an understanding of the relationship between learning cycles and classroom activities and their effects on individual lessons and the broader curriculum. Now, the complex interrelationship of lecture, demonstration, laboratory, all these are activities that the teacher you can do in the classroom, and you should understand them. So as a teacher, you need to help your students work and think like scientists. So as they are working, they should also be able to think like scientists. All right. I will find out the meaning of the E's and then give them to you as we proceed. You should also have knowledge of instructional resources. So what are some of the resources that you can use for?
I said for some of the E's.
Okay, yes. So what did you get?
I had engage.
Engage,
explore,
good.
Explore.
Engage.
Explore.
Explore.
Explain.
Explain.
Elaborate and evaluate.
Elaborate and evaluate. That is for the 5E. So you engage the learners, and that is where you elicit their prior knowledge. You explore. So here, like the issue of low current and low voltage, they will now explore through a practical activity. Explain. So based on their observations, they give the explanation to what they have observed. Then the teacher, you now elaborate, you throw more light. Then you find out the understanding. That is the evaluation stage. So that is a learning cycle. Thank you very much, Matthias. All right, so you should also have knowledge of instructional resources. What are some of the resources you can make use of? Yes. Yes, Benjamin.
The textbook.
Come again.
The physics textbook.
Good. The physics textbook. Yes. Any other? Any other? All right, let's proceed. Now let's look at the typical knowledge base. So we look at the general or generic knowledge base, and we saw that you must have content knowledge, pedagogical content knowledge. Now let's look at what is typical for the physics teacher. So as a teacher, for you to be able to teach physics concepts well, there are certain knowledge and skills that pertains to science that you must have. And these are some of the knowledge bases that you need to have. So what we are going to do now is that you look at this typical knowledge base, you pick one of them, and you explain to us. Is that clear?
Yes, sir.
All right, so who is starting? Benjamin. You pick any of the knowledge base and you share with us what it means or what you think it implies. Yes, Benjamin, or I should move on to Matthias.
Yeah, please move on. I will come back.
Okay, Matthias, your brother said begin.
Okay,
Matthias.
so, yes, sir.
Yes.
I think I'll talk about the knowledge of applied physics.
Come again.
That's applied physics knowledge.
Okay, knowledge of applied physics. Yes.
Yes, please. So it's on how it's like it is the knowledge of understanding and then understanding physics and then the use of physics
Okay.
principles in a practical form or in real life to solve real life problems. That is the
Okay.
knowledge of physics to create or make an invention to help solve life problems.
That's wonderful. Yes, Gideon. Matthias, thank you. Yes, Gideon. Hello. Hello.
We can hear you.
All right. So we have knowledge of, okay, yes, Benjamin.
Okay. Please, can you hear me?
Yes, I can hear you.
Okay. So I'm to talk about knowledge of curriculum.
Hello. Hello, sir.
Knowledge of curriculum.
Hello.
Okay, continue. Gideon,
Yes,
wait
sir, I'm
for
talking about
Benjamin
the knowledge
to
of
finish.
physics and allied science.
Okay.
So I think.
Yeah, Benjamin, proceed.
Okay. So knowledge of curriculum. This means understanding of the topics and also how to teach. That is
Okay.
what topic to teach, the order to teach them, the way or the method that will be used to teach them.
Okay. That's good. Yes. Gideon, you can now come in.
Okay, sir. I was talking about the knowledge of physics and allied science, the first one.
Okay.
So in this case, I think you have to be a master of the concepts in the physics and also other related subjects like chemistry and mathematics because physics work hand in hand.
Okay. So as a teacher, you must have knowledge in all these areas and understanding of your learners. You know that your learners are coming from diverse backgrounds. In your classroom, you have the average learner, the above average, and the below average. You need to have an understanding of these learners, knowledge of the difficulties your learners go through, they are likely to encounter. Some of them may not like the mathematics aspect of physics. Some of them may not like the theoretical aspect of physics. Some of them always find almost everything difficult. And you should have a better understanding of all these issues. So having a better understanding of all these issues places you in a better position to explain most of the concepts in physics to your learners. Please, was somebody asking a question?
It was Akua, but he has muted
Oh, okay.
himself.
All right. So active learning, assessment, evaluation, self-assessment, reflective practice, all these are knowledge and skills that you as a prospective teacher, you need to have. Now let's look at the uses of these knowledge bases. So when you have an understanding of your learners, when you have knowledge of the difficulties your learners go through, knowledge of applied physics, knowledge of physics and related subject areas, what do we use these knowledge bases for? So one of them is that it serves as a guide for developing or reformulating physics teacher education program. So you realize that it is based on these knowledge bases that we introduce courses such as computer applications in science education. So we realize that we are in a world where the affordances of technology cannot be overemphasized. And so because of this, we have to train teachers to be competent to use technology in the and it also helps school administrators to make informed hiring decisions. So those of you who applied or have applied to some private business schools and you are working with them, you realize, I don't know whether you went for interview or not, but if you have gone for interviews, sometimes they find out how you address learner competent you are when it comes to some of these issues. And for prospective teacher candidates to also make info. Oh, that's not true.
It is. It is true.
Hello?
I say your voice.
Can you hear me?
Yes, but at a point your voice just fainted. Like we don't hear it, and it comes back.
Okay, so I was asking, when we look at the second point, the second bullet, we are saying that the typical knowledge base helps prospective teacher candidates to make an informed choice about the school in which to enroll. So I want to find out, what informed your decision to enroll at UCC? Yes. I hope you heard me now.
Yes, sir. Sir, we did.
Yes, Matthias. What informed your decision?
Okay. Because of one the structure. One is the structure of the school, and then also how the goal of the school, how the standard they want to maintain a particular standard. So they tend to train people to also have those qualities. That's the reason why I chose UCC over other schools.
Okay, so the reason why you chose the University of Competitive Choice, the #1 university in Africa, and we are doing very well. So you realize that based on some of these ideas, you get to know that, no, if I am a teacher trained from UCC, I will get to the field, and in fact, I will be very competent on the field. So that is the use of some of these knowledge bases. And we also use it by in-service teachers for self-assessment. So sometimes we look at this knowledge base and I ask myself, how well am I able to use technology to teach? How well do I have knowledge when it comes to learner assessment? And based on this, I'm able to do a self-assessment. And when we also want to improve our practices, we compare our performances against the established standards. And we can also plan professional development sessions based on the deficiencies that we will observe in this knowledge basis of the teacher. Now let's look at teacher competence. What is competence? We are in a country where we always say this politician is not competent. When we say competence, what comes to mind? What is competence? We have been using this word a lot. You are competent, you are not competent. Yes, Benjamin?
Their capabilities
Okay.
of doing things.
Come again.
Their capabilities of doing things or bringing something new or something valuable to the society.
Okay. Yes, Matthias.
Okay, so competency deals with your ability to perform a task or to do something. So if you are competent in something, means that you'll be able to do it.
Okay.
Yeah.
So it means you are fit for purpose, right?
Exactly.
Good. So when you are competent, it means your fitness to perform a task. So in the area of teaching, then we will say that if you are competent, then it means that you possess or you are in the possession of a certain kind of skills, a certain kind of knowledge. You have the appropriate attitudes, the experience for successful performance when it comes to the teaching field. So for a teacher, for you to become competent, you must acquire basic classroom skills that you need to present and navigate lessons. So some of these skills, as we mentioned earlier, lesson planning, set induction, presentation, how you vary stimulus in your classroom, proper use of audio visuals, your questioning skills, how you end your lessons. All these are skills that you need to become a competent teacher in the classroom. Now, some of the competencies that you need to demonstrate as a physics teacher include your ability to critique a poorly written physics examination. So in the course of your teaching or where you'll be working, sometimes a colleague may set questions and bring to you for you to critique. You should be able to critique questions that are poorly written, and you should be able to also offer a best or a better way of writing that particular question. You should be able to create a physics examination with tasks that is inspired by physics education research and evaluate knowledge, skills, and disposition. You should be able to create a detailed multi-dimensional scoring rubric. So when you prepare subjective questions, what we call the theory type of question, you should be able to provide a rubric or what you call the marking scheme to the question. You should be able to document the process of developing, teaching, evaluating, and reflecting upon a model of inquiry lesson. So all these are competencies that you should be able to demonstrate. Then you should also be able to identify one or more learning theories. So some of these learning theories and how they inform teaching and learning in the classroom. And finally, you should be able to actively and meaningfully participate in all class lesson discussions and other class activities where you contribute ideas that reflect more than a recitation of the material that is being read. So you need all this. You should be able to demonstrate all these competencies when it comes to teaching and learning of physics. Please, any question, any submission? Hello?
Hello,
Hello.
sir. We can hear you, sir.
Yes, any question, any submission?
Not from my end.
Yes, any submission, any question? All right, so I think in the absence of any other questions and submissions, we can bring our session to an end today. Let's take note that from next week, We will be meeting from 7 a.m. to 9 a.m. as we agreed earlier on. So your colleagues who couldn't join today, please let's inform them that from next week onwards, our lectures will be from 7 a.m. to 9 a.m. Then again, we'll be using the platform we created last year for curriculum studies. I believe all students on that platform are supposed to take this course. So we only change the group name to reflect the current course that we are doing. Yes, Benjamin, your hand is up.
Okay, sir, thank you.
You're welcome.
During the lesson, I had a call from our coordinator that our own is face to face, but later he has changed to online. So we will still join the online.
So you are supposed to have it online, right?
Yes, please.
Okay, that's fine. Yes, any other issue? Any other issue? All right. So I will share the slides with you on our WhatsApp platform. On this note, we will call it a day. Have a nice day and enjoy the rest of your lectures.
Thank you. Bye bye.